Hello. In this video, I'm going to give you a big old overview of dimensional analysis because there are, oh, hi computer. Sometimes it says hi to me. This is a process that has a lot of details that go into it, and I have some pro tips and some common pitfalls that my students often find themselves doing. So I want to do a couple examples with you. One we would call a one-step dimensional analysis problem, and the other one I would consider a multiple step. So let me pull up my examples that I made for this video. They're kind of random. But our first one is a hybrid car gets a gas mileage of 32.4 miles per gallon. How many gallons of gas would it use for a 75-mile trip? So this is not a chemistry question, right? But this is the type of question where my chemistry mind automatically goes to dimensional analysis because I never know, should I multiply? Do I divide? What do I do? I let the units tell me what I'm going to do. So let me show you how my brain picks apart these problems and also how it applies to the dimensional analysis problems for chemistry class. So in this problem, we're given two numbers. We're given 32.4 and 75. The key of knowing how to start this off is for looking for things that can be useful. So this problem doesn't have an equation in it. Sometimes you might be given an equation, say kilograms to pounds or something like that. This one instead has a ratio, and we can identify a ratio because we see the word per. Whenever you see the word per in one of these word problems, that should be a big old alarm that this is going to be a very useful number for you. I underline the entire ratio and I rewrite it as a fraction. What we can do is we can write this with everything that goes before per, that is before per, goes on the top. So 32.4 miles per, everything after per goes on the bottom, per 1 gallon. So what this means is that these two are equivalent. 32.4 miles is equivalent to 1 gallon. Now, our equation may use this fraction. It may use the opposite. Okay, we might have to flip this fraction, 32.4 miles underneath 1 gallon. I'm going to teach you how to know which one to use. These two fractions, they are called conversion factors. If you have a ratio in your problem for Chem 100, you're never going to start with that. And we call our starting amount our given. And I usually put that as a G. In higher level classes, you might see that as a given, but your wanted unit would also have a per in it. So our wanted is the unit that we're asked for. So after I underline any per statements that I have, any equations, now I look for what am I starting with? Where am I going? These fractions here, they're going to help me get from my given to my wanted, but they're not going to be the given or the wanted. So I look for any other numbers that might be given to me. That 75 miles, that's going to be our given. So for Chem 100, our starting unit will always be a simple unit. You'll never have a per in it. Same with our wanted. The wanted we can usually find by looking for a unit that does not have a number with it. It will often be after a question word like how many or how much or calculate. Here it is after how many gallons. So our wanted is gallons of gas. Okay. So once we have any fractions written to the side, we have determined our given and our wanted. We can see if we can do this with just one step by looking at our given and our wanted units and determining if I can relate those directly to each other. So miles and gallons, those are the two units that are in my fraction, so I can do this with a single step. So what we're going to do to start the calculation is I always rewrite the given. 75 miles. I like to write that over a 1 since we're going to be multiplying by a fraction. So I multiply that by, I put a little multiplication sign, a line. Notice that when I put my given over 1, that 1 is just a placeholder. It does not have a unit. It does not even need to be there. It's just helpful for when we do our entire problem, knowing that 75 will multiply along with the other numbers on the top. Now, to fill out the fraction, we always put units first. Why? Because the key to these problems is canceling out our given units to give us our wanted units. So if I want my miles to go away, I need to put miles on the bottom of my fraction that I'm multiplying by. This gives me 1 miles on the top, 1 miles on the bottom. They're going to cancel. I'm going to, if I have a direct relationship, so I can just do this in one step, I always put my wanted unit on the top. And now I know which conversion factor to use because I need to use the version that has miles on the bottom so it can cancel out. So we're just going to plug in our numbers right like this. So 1 goes with gallon, 32.4, that goes with miles. Now, as you get better at these, you won't always have to write both versions of the fraction. All you need to do, if we say we had just written this first one, we see that 1 always goes with gallon. So if my gallon is on top, 1 needs to go with it. My 32.4 is with miles. So if miles is on the bottom, so is 32.4. This is our calculation here. How do I know what to enter into my calculator? I multiply by anything on the top. I divide by anything on the bottom. I can ignore ones. So my miles have canceled out, forgot to cancel out my units. And now to put this into my calculator, I'm going to take 75. And because 32.4 is on the bottom, I am going to divide by 32.4. So when I put 75 divided by 32.4, we get a big long number, 2.3148, blah, 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 blah. Now my unit is gallon, and I decide how to round by looking at sig figs. So if I'm looking at my sig figs here, 75 miles has 2 sig figs. And miles per gallon, that is a quantity. Most rates, if I see a per, most of those have to be measured. So the 32.4 has 3 sig figs. So I'm going to take the smaller of the two, that's my multiplication division rule, and I'm going to round to 2 sig figs. So I am given 2.3 gallons, and that is our answer. Okay, now let's look at a more complex one. This one, we're going to use the prefix chart so we can practice using our prefixes a little bit. And we're asked to convert 348 centigrams into kilograms. Now, this problem is pretty straightforward in knowing where I'm starting and where I'm ending. Our given is 348 centigrams. My wanted is kilograms. This problem can be particularly tricky for students if they do not recognize that this is a case where we can't directly relate the two units. So whenever you're writing a relationship using this prefix chart, one of the units in your equation, so let's say we're talking about centigrams, right? I cannot put equals to kilograms because I already have centi in here. The only thing centigram can relate to is grams. When I'm using this prefix chart, one of the units has to be a base unit. So I can go from centigrams to grams, and that's the only thing I can go from centigrams to. So that means that we're going to have to do this in multiple steps. We're going to start with centigrams. Whenever we write our map, we always start with our given unit. And we have to make sure that the last unit in my map is our wanted unit. We can only go from centigrams to grams. That's our only choice. So whenever you have a given and a wanted, we both have a prefix with the same base unit, centigrams, kilograms. always go to that base unit grams in the middle. So now that we get to grams, we can go from kilograms after that by writing a separate equation, grams and kilograms. And we're going to use both of these equations. So let's review how we write each equation. So equation 1 relates centigrams and grams. I put the one with the bigger unit. That's the one that's higher up, grams. I look at my prefix, 10 to the, centi is 10 to the negative 2. So I find the prefix, I find the power of 10. I make it positive. We're positive people. I make all the powers of 10 positive. And the reason why I can do that, I put the 1 with the bigger unit. So I've got a whole lot of little units that fit into that. Let's write our second equation. This is relating grams and kilograms. Once again, I put my 1 with the bigger unit. So kilo is higher than grams. I look for the prefix in that equation. There should only be one prefix. Now this time the prefix kilo is not where the blank is. That's totally fine. There's going to be one blank and it might be with the prefix, it might not, because the bigger unit changes whether it's prefixed or not. But I find the power of 10 with kilo. That's 10 to the third. It's already positive. So I just plug it in like this. Okay, so I have my given wanted, I have my map, and I have my two equations. So to start my calculation, I'm going to rewrite my given. 348 centigrams. I like to write it over 1 to have everything in a fraction. When you write it over 1, do not put any unit. That's just going to be by itself. I'm going to write a multiplication and a line just like we did for example 1, but here I have multiple steps. I look at my map and that tells me how many multiplication signs I need. I'm going to write a multiplication sign with a fraction line for every arrow in my map. This map has 2 arrows, so I'm going to write 2 multiplication signs. 1, 2. Okay? Great. Now we're going to fill in the top units. So just like we did with the one step, we're only filling in units and then we get to the numbers. Here, I like to fill in all my top units because my map tells me what they are. Our map has 1, 2, 3 units in it. Our setup has 1, 2, 3 fractions in it. The tops of the fractions are reflected in the map. We start with centigram, we go to gram, and then we go to kilogram. So the map is reflected in the top of the fractions. Now we can go back to the method that we used in the single step, where I have to make sure to cancel out my units. So my units from my given will always, and it's sometimes like students like to write a little arrow there in the multiplication sign. That unit we'll see again in the next fraction on the bottom so that they can cancel. And then the top of that fraction gets written down in the bottom of our last fraction, so that one cancels. After everything cancels, that leaves us with the very top unit. In these problems, your given will always be the top of the last fraction, no matter how many fractions you have. To fill in the numbers for these fractions, I'm going to look at one at a time. So let's concentrate on this first empty fraction. I see that I have grams on top and centigrams on the bottom. So I'm going to find the fraction that has those 2 units represented. That's our first equation, centigrams and grams. So that's what we're going to use for this fraction. The numbers and the units from the equation stay together for the fraction. 10 to the second is with centigram, so it needs to stay with centigram. I see that centigram is on the bottom, so I'm going to put it on the bottom. I see that in the same equation, 1 is with gram, so 1 goes with gram. I cross out this equation. We are done with it. I cancel out my centigrams. That fraction is done. Now we can move to our last fraction. I look at my units, kilogram, and gram. I find my equation that has those two units related to each other. That's our second equation, grams and kilograms. Just like we did for the other fraction, I look at one of the numbers, 10 to the third. I see what its unit is. 10 to the third has to stay with grams. Therefore, 10 to the third will go on the bottom where grams is located. 1 has to stay with kilograms, so 1 goes with kilograms here. My grams cancel out. We're all done with that. We're left with kilograms, which is our wanted. We are ready to calculate. To do this calculation, I'm going to enter into my calculator 348. 10 to the second is on the bottom. I type this into my calculator as 1EE2. I like to use the EE button. On this calculator, you have to press the second and then the x to the -1 to get to that. It means 10 to the. Now, here's the part where some students make a mistake, and I just like to look at one thing at a time. Do you notice 10 to the third is on the bottom? Remember, top means multiply, bottom means divide. I'm actually going to divide a second time, okay? So I'm going to put 1. Now, yeah, you could do a multiplication there if you wanted to put things in parentheses to show that 10 to the second and 10 to the third are on the bottom. I just hate parentheses. So I avoid them when possible. So I just divide when I get to a bottom number. So we're putting 348 divided by 1E2 divided by 1E3. And I get 0.00348 kilograms. Let's look at significant figures. This fraction has 3 sig figs. The other 2 fractions have infinity. Whenever we have units compared to each other that are in the same system, in this case metric, it's a defined relationship. So whenever I'm using this prefix chart, it's infinity. So we need to keep 3 sig figs. Our answer is written has 3 sig figs. I can represent this in scientific notation if I like. That involves moving the decimal after the 3. So I have 3.48. And then I count how many places the decimal moved. 1, 2, 3. Our original number was less than 1, so it's a -3. So either of these answers is acceptable. So I hope this overview of a couple examples helped to clarify this process. It's a really powerful process, and I hope you get an appreciation for how canceling out units can help us with math.